All right, everybody, so today we're going to learn about this word called a polyhedra. And we did a bunch of different activities in class to help us compare what was a polyhedra and what wasn't a polyhedra. And in order to be successful today, we have a lot of vocabulary that we need to know so we can be precise with our mathematics. So just a clue, I have all these page numbers. These are talking about the back of your book. This will help you find where all of these vocab words are located. So for us, a polyhedra is a three-dimensional figures with faces that are polygonal regions. Fancy way of saying they look like polygons or shapes that we know how to find the area of. The next thing we need to know is a net, which is a two-dimensional representation of a polyhedron. So essentially, if you had your figure, your polyhedra, and you cut all of the edges and laid it flat, that's going to be your net. The next thing we're going to talk about is an edge. An edge is a line segment in a polyhedra. And just to help us see this a little bit better, on my figure down here, something like that would be an edge. Okay? And with an edge, there's a little bit more we can say about it. We can say it's a line segment in a polygon. It's called an edge. And it's a line segment where two faces meet in a polyhedra. So you need two faces to meet at a line. Okay, and the last one we're going to talk about is vertex. Vertex is when we're talking about just one. Vertices is when we're talking about more than one. And it's essentially a point, or I like to think of it as like a corner where two pieces meet. So this is a vertex. This is a vertex. This is a vertex. This is a vertex. There's tons of them. Now again, when I have multiple, we then call them vertices. So for this picture, it's asking us how many faces do we see. Let me just kind of go through and clear all of these colors so they don't get confusing. Well, I can see that I have a face here. There's one. Here's two. Here's three. Here's four. Running out of colors. Now here's the thing you have to be careful with. It looks like four, right? Well, there's also the back. So if I have four in the front and then there are four faces in the back, I'm going to have 8 faces. Next, how many edges does it have? Let's do this in our yellow. Here's 1, 2, 3, 4, 5, 6, 7, 8, and there's also some more in the back. 9, 10, 11. This shape has 12 edges. And last, how many vertices does it have? 1, 2, 3, 4, 5, and 6. 6 vertices. All right, so when we break down our polyhedrons a little bit farther, we can see that there are two specific types that in this class we're going to be using a lot. And the first one is called a pyramid. So a pyramid is a type of polyhedra that has one special face called the base. All of the other faces are triangles that all meet together at a single vertex. So all of the other faces are triangles that meet together at a single vertex. So for example, if I have a box here, here's my single vertex. This is going to be my base. And when I draw everything up, they meet this guy as triangles. That's a pyramid. So the other one we talk about a lot is a type of polyhedron that we call is a prism. And it is a type of polyhedra with two parallel faces that are identical copies of each other connected by rectangles. So two identical with two identical faces that are identical copies of each other connected by rectangles. So for example, if I draw a base on top and a base on the bottom, these are exactly the same. And then when I connect all of my vertices, they make rectangles. Oh, so they want us to draw an example of a pyramid. So let's draw a different one. Here's going to be my base. And a pyramid is something that meets at a point and makes all triangles to connect. There's my pyramid. What about a prism? So here's my prism. I'm going to have two identical pieces. I have a top and a bottom. They are identical, except I made them different colors. And then I connect the corners, and it should form rectangles. Is the below figure a polyhedra? No, it does not have faces. Connected by edges. See, we have these curves, and once we have these curves, it no longer works.